Welcome back to Decoding Complexities. I'm Pradeep. Alright, so in the last video, we left off with the idea that a simple list like 4, 1 is actually a vector. It's an arrow with a magnitude or length and a direction. Now, the next logical question is what happens when we add two vectors together? Let's imagine we are on a grid and you have two vectors, vector A, which is 4, 1, and vector B, which is 1, 2. Adding a plus b is like taking a journey. First, you follow the path of vector A that gets you to the point 4, 1. Now, from that exact spot, you follow the path of vector B, which is one step right towards x-axis and two steps up towards y-axis. The result is a new vector C, which is an arrow from the origin directly to your final point 5, 3. This is called the head-to-tail rule. Now, let's look at the math. If A equal to 4, 1 and B equal to 1, 2, how do we get C equal to 5, 3? We just add the corresponding element. The first elements corresponding to x-axis 4, 1 gives us 5, and the second elements corresponding to y-axis 1, 2, which gives us 3. It's the same element-wise addition we would do with a normal list. It really is that simple. Here is how we can do this in NumPy. We create a vector A as a NumPy array of 4, 1 and B as NumPy array 1, 2. And we simply use the plus operator C equal to A plus B. And the result C would be the NumPy array 5, 3. For vector operations, we always prefer using NumPy, as adding two lists does not do element-wise addition in Python by default. Instead, it appends the elements of second list to the first list. So, why is this useful? In things like game development or physics, you use vector addition to combine forces, like your character's movement and the force of the wind. In machine learning, it's a core operation used everywhere. If that was helpful, hit the like button and subscribe so you don't miss the next video, where we will look at what it means to multiply a vector by a single number, also known as scalar multiplication. Thank you for watching.